Hi, everybody. My name is Pamela Dingle. Welcome to Fun with Flags. Oh, no, wait, that's something else. Introduction to Identity Standards, which is about as geeky as Fun with Flags, but I like it better. So it's great to meet you all, and especially hi to the ladies in the audience. I see you. Sometimes it feels like we fade away, so. All right, let's get started. I have 45 minutes, which is not a lot of time to talk about standards at all. We're going to cover 4 standards. And so that means I have 10 minutes to talk about each of them, and we'll try and keep to the timeline on that. So how many people have not seen this diagram yet? Oh, what a shocker. Oh, a few. There's a few. All right. So this is sort of a classic right now, especially around Azure AD. The identity is the control plane diagram. And it's beautiful. It represents your relationships to all the devices and all the applications and all the communities that you might need to manage in your life and identity. What does it really mean, right? Arrows are wonderful. It's amazing what you can represent with a little arrow that points at something. But if you actually have to implement it, then you have to get a level deeper and you have to understand what does it mean to have a trust relationship with a device or have a trust relationship with a remote domain. So what we're going to talk about today is literally what underlies those little arrows. We're going to go through them one by one and talk about what the business advantages are to using standards in those cases, what the architectural differentiators might be, and why you might want to choose them. And then we're going to do a little tiny demo and geek out on things that you can do today to look at the standards in action so that they don't have to be abstract concepts. They can actually be things you look at and see and take in pieces. So standards are the backbone of so many things today. If you've ever screwed a light bulb into a lamp or you've ever plugged that lamp into the wall, you are using standards, right? When I can buy a light bulb from one vendor and I can throw it into a lamp from a completely different vendor, the reason why I can do that is because somebody has written down to the tiniest degree the exact dimensions of the base of that light bulb, the exact thread of the screws it winds all the way in, the exact current that's going to be pulled. All of those things have been minutely defined so that somebody else, like me, can walk in with no understanding of electricity and not kill myself. That's really good, right? You can plug things in without understanding the hydroelectric plant and all the bits that run that hydroelectric plant, right? You just get to look at the layer of abstraction that is an outlet, an electrical outlet, and you just need to know you plug the thing into the outlet, right? That is the holy grail of standards, and not just physical standards, but identity standards as well. So I run a team, a fairly newly formed team called the Identity Standards Program at Microsoft. And we have a crack team of standards professionals who travel to meet other crack teams of standards professionals in various amazing places in the world. And then we shut ourselves up into little tiny rooms. And we don't look at anything, and we talk about, the length of a query string that isn't going to exceed, the maximum memory in a browser, or worse, in a little flip phone, right? So we get together in order to be incredibly pedantic, and in order to work out identity standards, that can interoperate between many companies. So we tend to work with big companies like Google and Cisco and Verizon. We also work with smaller companies that are niche experts in the space, and individual contributors as well. So it's hundreds of people all arguing with each other. Now, if that sounds like your cup of tea, then you should be a standards person too. You should come talk to me. It's tons of fun, actually. All right, so let's take this diagram to pieces, right? It turns out that really what we're talking about when we talk about identity as the control plane is a transmission of trust and data, right? So a relying party is an identity standards name for an application or a resource that is relying on information rather than storing it itself, right? So if you were to take this diagram and you were to get rid of the arrows, get rid of the central control plane, what would you have? You would have resources in your cloud, resources on premises, all separately storing passwords, all separately performing login, using login forms, performing account recovery with separate password policies, right? Separate password lengths, separate expiration, right? It's chaos, dogs and cats living together. And we're trying to bring order to that chaos. So the way that we do that is we configure these applications to listen rather than to collect, right? We send them secure messages or we provide APIs for them so that they can get the data they need rather than having to ask the user for it. And what that does is it changes the relationship that the user has with the application, right? Instead of the user having separate individual relationships with all these apps, now they can just simply go to the app and be redirected home to authenticate or redirected home to authorize a transaction and then head back to their app and they can just simply use it. Okay, so that's what a relying party means. And in this case, we're talking about other applications relying on information that Azure Active Directory is sending. So the other side of the relying party is an identity provider. And that's what Azure Active Directory is here. So the number one thing that we do to rely on data today is single sign-on, right? Or otherwise known as federation. There are multiple protocols that can do federation. You may have heard of one, for example, called WS Federation. That is one example that I'm not going to talk about here. And it's really cool what federation does. All federation is a note from your parents to your school saying, please let little Seymour get access to the zoo. Right? You want Seymour to go to the zoo, you have to give permission, right? That's all the federation is. Federation is two authoritative parties agreeing to trust each other and then sending messages about users, right? So when I want to go to Salesforce, for example, I may start at Salesforce, or I might start at my little app launcher page or wherever it is, right? But when I get redirected across to Salesforce, I'm literally being redirected with a structured document that it has a signature that is from, issued by an authoritative party, in this case, Azure Directory. It is intended for an audience, and in this case, the audience is Salesforce, and it describes the user in a way that can be validated and in a way that's structured and agreed upon ahead of time, right? So that's all the federation is, but it's super exciting because users love it, because it's seamless to them. So once you log in one time, what happens is you create a session or you create an authentication context of some kind at your identity provider, right? And then that authentication context can be leveraged over and over and over without having to bother the user again. So the first time you go to an application, it's going to prompt you to authenticate. It's going to create your session, your context, however you need to. And then after that, boom, you get to log in the second time. It just heads over to the IDP. The IDP says, oh, yeah, I know who that is. Here's your letter from the parents, right? Redirects you off to application number 2, application number 3, right? All of a sudden, the user has a much, much better experience. But at the same time, it's amazing for the security crowd, right? And if you're going to go back and talk to your, if you're going to manage upwards when it comes to federation and web single sign-on, what you need to realize is that it allows you central control, right? You create one authentication ceremony that users know, that they trust, that they understand, right? You always send your users back home to that central authentication ceremony. And what that means is now you get visibility into everywhere that they're logging in, right? You can see it when they're SAML authenticating or OpenID Connect authenticating across the applications. And because you can see it, you can start to see patterns as well, right? So there's huge security advantages. There's huge visibility advantages, right? You understand which of your users are even logging into the applications that you may be paying so much money for. And of course, the other thing is that your risk surface goes down because all those applications are not storing passwords, right? So when you terminate your user, you terminate them one time, and all of these applications stop working because they're relying on federation. And when federation refuses to authenticate a user, then all of those apps just go away. All right, so we're going to talk about the granddaddy of all federation protocols, and that's SAML. SAML is what I call Death Star to Death Star federation, okay? So you have to have two entities that are, big and, capable of doing PKI, capable of parsing XML and SOAP, right? Capable of, a big fat pipe that they're going to put users down, right? And so SAML's great. SAML's been around for a long time, since I think something like 2001, 2002, somewhere in there. Okay, it was a lot of geeks who got in a room. They wrote like 800 pages of specification. Okay, this is no simple thing, which is why you really don't want to try to write your own SAML relying party. But if if you're trying to attach to an application and that application is SAML enabled, then you're golden, right? You just select it, you set it up. Most products are now kind of click button connect for things like SAML. They abstract away the many, many details that you may care about if you want extra security, things like signed authentication requests or fancy encryption, but you don't have to care about them. One thing, though, and the reason why I'm even going to talk about other protocols is that SAML doesn't really work for native mobile apps, right? It was written before cloud was really a thing. And so, imagine if you wanted to write a native mobile app and you had to put a private, somehow store a private key on your mobile app, and you had to somehow parse SAML or parse XML and SOAP, right? I mean, your developers will kind of curl up into little balls and start rocking, which might be fun. It all depends on, where your sense of humor is. All right, so let's look at this. Let's see if this baby works now. So it's really easy to look at SAML type of transactions, and they're everywhere. Once you know what to look at or look for, you're going to realize that you're being redirected, you're being federated all over, and you never even knew it. All right, so we're going to use a little tool here called SAML Tracer, which makes it a lot easier to see. Now, the question is, how big does this have to be? We will find out. All right, so I'm going to start at Salesforce, and I'm going to perform what's called relying party, RP-initiated or SP-initiated single sign-on. So what that means is that I'm starting at the place that wants to rely on the data. So the first thing I have to do here is perform what's called IDP or user discovery. So when you see these sort of things in action, generally what happens is Salesforce has to figure out who the heck your identity provider is, right? So they may do that by prompting you for an email address and looking at the domain of your email address. They may do that by showing you a bunch of pictures. You've probably seen the login screens where they show you Facebook and Twitter and all the little providers you can click on. In this case, it's been pre-configured. I have pre-configured it so that I can choose HIPS to Bank Azure Active Directory as the identity provider. All right, so let's make sure we have everything we need here. We'll clear this. We'll make it bigger in a minute. All right, so I'm going to initiate my authentication right now. And I've already been redirected back to my identity provider, which is Azure Active Directory. And I'm going to sign in. And I'm in. So that was cross-domain federation that you just saw, right? You can tell the difference, really, between logging in with the Salesforce login page and logging in with the Azure Active Directory page, right? Except instead of 2 sets of passwords, we only have 1. So now let's go look at what that actually showed up as. All right, is that big enough? Should I make it bigger? All right, so there's this big thing that says SAML. It's hard to miss. And you'll all have to tell me if this is even remotely readable for you. But what we're basically looking at here is the actual SAML response that was sent. So I can show you the request. This is the response. So let me just highlight some things. Issuer, right? In the note from parents type of paradigm, that's your parents, right? This is the authority that says little Seymour should be able to go to school, right? You scroll down a little bit more, you're going to see things like an X509 certificate, right? This entire assertion is signed, and the signature can be validated, right? So that's how the security model works. So nobody can send pretend notes for little Seymour Skinner to get him into crazy events. You can see here, so there's your signature, and here's the X509 certificate that goes with it, right? It's all there for you. And then the other interesting thing, if I scroll farther down, hopefully I don't make you motion sick. All right, so you can see here there are attributes, right? So there's a tenant ID attribute, there's a name attribute, so there's Seymour at Hipsta Bank. His last name is Skinner, right? So this structured document has everything in it that's necessary to describe both the moment of authentication. So it will tell you how Seymour authenticated, it will tell you the level he authenticated to, it will tell you when it happened, and also this document is only good for a very, very short period of time. So that even if somebody manages to steal this document and replay it, there are multiple security mitigations to making sure that that doesn't matter, right? One is once the relying party sees this particular document, it has a unique identifier, it is supposed to reject any copies, right? So it has what's called replay detection. So you can go in here, you can play with this, right? There's nothing here that's special or fancy. You just need to find 2 sites where you know that they're SAML enabled, and then you can go look at this. Now here's the downside to that, right? You can go look at this, and if you can go look at this, lots of people can go look at this, right? So the signature means that it's tamper-proof, but it's not, it can still be examined, right? And the browser is not necessarily the most sanitary of places to be tossing around fancy assertions. And this will become important in a minute. All right. Heading back into protocol land, there is another paradigm whereby external cloud resources rely on identity information or other data, right? And those are RESTful APIs. So this is an example of what happens today, right? For any platform that's not using standards to protect their APIs. So what you can see here is that this standard is something called BASIC, right? Basic authentication. The idea behind this is you take the user's primary credentials, their username and their password, and you concatenate them with a semicolon, no, a colon in between, and then you base64 encode them, and then you send them on every single page fetch. Okay, so every time you call an API, your user's primary credentials are embedded in that call, thousands of times. Okay, and maybe, how many APIs do you all run, right? Maybe you've got 100 APIs. Maybe you've got 100 administrators managing APIs, right? Maybe one of those API managers messes up their HTTPS, right? It messes up their transport layer, and it all happens in HTTP instead of HTTPS, right? Maybe one of your administrators misconfigures their API so that they're logging all of these credentials to a file that then goes into an Amazon bucket on the internet, right? All of these things are possible, right? Not only that, when you have APIs that have to validate people's primary credentials, right, 2 things happen. One, you have to give the API owner a highly privileged account in order to perform that validation, right? But number 2, you know, they could be evil. They could be harvesting all these credentials. The other thing is, if you're using APIs in this fashion, you can't move to MFA very easily, right? If you want to go passwordless, and all of your APIs still think that they're going to get a string that represents a password, then you've got an architectural problem on your hands, right? So this is not good, but it is the de facto standard, or it was until OAuth 2 came along. That's what we're going to talk about next is OAuth 2. OAuth 2 uses something called bearer tokens. Bearer tokens are like coupons, right? I can give you an admit 1 ticket for the movies, right? Technically, it's worth, I don't know, how much are movies now? $27,000 to go see a movie, right? But I'm going to give you a ticket. So you don't get to trade that ticket for $27,000 anymore. You get to trade the ticket only for a movie, right? So if I steal your ticket, I don't get to see the movie, right? But I don't get to spend the equivalent money anywhere I want, right? So that's what bearer tokens do. They are scoped, tiny credentials that are only good for certain resources, and we let those fly around the internet, right? Keep your passwords at home. send out these little tiny coupons as the authorization header in your APIs, and then everyone's happy, right? Your API owners never see the passwords, so there's plausible deniability all the way through. All right, so OAuth 2, the cool thing about OAuth 2, right, where SAML is Death Star to Death Star, OAuth 2 is Death Star to TIE Fighter. Okay, so OAuth 2 has an authorization server, and that authorization server takes on almost all of the burden for the security of the system. Okay, so it has to run over HTTPS. It has to have certificates and secrets and all those sort of things. But it can support very small pieces of software, right, that are asking for bearer tokens. Okay, and that's all that OAuth 2 does, right? It allows a little piece of software to ask for a token and get a token in return so that it can play it at APIs, right? Super easy. No identity. There's no identity in OAuth, right? It's like, please, may I have a ticket, right? I provide some kind of credential, and I get a ticket back, and I call an API, right? This is very, very important. You'll see why in 1 second. All right, so let's look at what OAuth looks like, because it's a bit of an abstract plan. And I'm going to exit out of this so that you can see I've got nothing up my sleeve, which probably means it's going to go terribly wrong. Oh, right. Thank you. It's a good thing someone's paying attention. All right. All right, so I'm going to start up my SAML tracer again so you can see what's going on. Now, this is a piece of software that is written in PHP. I got it yesterday off of GitHub, and I have modified it. And I need to tell you just how incredibly artistic I am. I'm just going to warn you now. Okay, so you can see I am performing the same dance that I performed in SAML, right? Oops, and I also... Turns out talking and typing passwords are bad. Yes. Okay, I just performed the same dance that you saw in the SAML dance, okay, but I did it now using OpenID Connect. So OpenID Connect we're going to talk about in a minute, but what I've gotten out of that is an access token. And I want to talk about this access token, but first let me pull up the SAML trend. All right, let's pull this up and look at it. So now we're going to look at exactly the same kind of paradigm, right? Is that the one? Yes. All right, so in this case, I have a very similar request. Okay, I've made a request. Actually, that is the response. I'm going to make the request. Yeah, that's all right. I'll just show you the response. What I've done is I've made a response. I've basically said, hey, I want to log in. And what I'm going to get back, instead of an assertion that has all the data in it, I'm getting back this little thing here, which you can see here, which is called an authorization code. Okay, and if you look at, if I go back and look at my piece here and look at the parameters, all I get back is this code. This code is an abstract nothing. It means nothing. What it is it's an artifact. It's an ephemeral, tiny little one-time use code that's traveling over the browser, so in a browser redirect, back to my relying party. What my relying party is going to do with that code that you can't see because it's not in the browser is it's going to make a RESTful fetch to a known secure endpoint, and it's going to trade that code for the actual data, for the actual access token and ID token, right? So this is a very different paradigm from SAML, right? SAML's all in the browser. This is a front channel beginning and then a back channel finish where I can now pull out this data. Now you have to check this out. This is pretty cool. Here's my access token. It is base 60, it is a JOT. So a JOT is a JSON web token, and it is a structured document, very similar to SAML, except it's not angle brackets, it's curly brackets, which we all know is much better. I mean, thank heavens the world has evolved the way it has. All right, so let me make this bigger. So what you can see here, assuming you can see it at all. All right, so you can see the header, right? In the header, we're talking about the algorithms by which it's signed. And here's the payload, right? So the payload is quite a bit more readable in OAuth and OpenID Connect than it is in SAML. Okay, so this is very interesting. You can see here all the same information: family name, given name, IP address, name. Okay. Now, you will remember that I said earlier that OAuth doesn't have identity. Well, here's the really interesting thing. This access token is what is opaque to the client that receives it. Okay, what that means is it could have any format. Okay, this what you're looking at right here is actually the Microsoft proprietary access token format, meaning that if you want to write to Microsoft, you can write to this format, right? But if you've got a third-party client, they don't know what this access token is going to look like, right? So it looks a lot like an ID token. It is not an ID token. What you need ID tokens for then is for identity and for Web Single Sign-On, and to do that, you need OpenID Connect. So let's talk about OpenID Connect. OpenID Connect is like SAML and OAuth had a baby, right? We get two types of tokens. We get an access token and we get an ID token. And the difference between these two things is exactly what I just said. An access token is destined for the APIs, right, for what we call resource servers. The ID token is destined for the client, right? So you can communicate to the client that's making the call that the person is Seymour and that his last name is Skinner, right? And all of these wonderful things, and you can do it in a way that anyone can understand. So I can write third-party OpenID Connect compliant clients that can understand ID tokens, right? So in this case, if I go back now to my demo screen, actually I won't just for time, because I want to make sure we get to FIDO at the end. But if I were to go back and look at my ID token and my access token, they're actually quite similar if you look at them in the Microsoft paradigm, right? The access token, the Microsoft proprietary format, actually has way more data in it than the ID token, because in order to be conformant to the specification, you should only send certain pieces of data when they're asked for, right? And in fact, if we have time, we can go back and look at that because it's kind of interesting, right? The actual OpenID Connect request had very little data in it, and therefore the ID token that results has very little data as well. But let me just talk about OpenID Connect for a minute. Why should you care, right? SAML's awesome. Why would you even care about OpenID Connect? Well, OpenID Connect can handle both web and native and cloud and scripts, all of these things, right? So if you're just writing a script that needs an access token to call an API, then you can use OAuth. The only difference between using OAuth and using OpenID Connect is that OpenID Connect is a few more parameters that you add into the OAuth call, okay? The other thing about OpenID Connect is it is for and about identity, and therefore it is for and about users, right? So you don't get to do the script scenarios with OpenID Connect. You have to use these browser scenarios. So there are 4 scenarios that OpenID Connect can handle, right? 2 of them involve a browser. Actually, sorry, 4 scenarios that OAuth can handle, 2 scenarios that OpenID Connect can handle. What you just saw was something called the code flow, right? And that's a request that occurs over the browser, followed by a fetch that's a back channel fetch, right, that doesn't go through the browser. It is considered the best practice flow unless you have other requirements. But why would you use OpenID Connect? Like, what are you going to talk to your bosses about when you go back to talk about OpenID Connect? Well, it is expanding. So SAML is what SAML is. Nobody's going to reconvene for a SAML 3.0, right? That's never going to happen. Whereas OpenID Connect is still growing. So we're working on scenarios, for example, in the OpenID Foundation for financial grade APIs, right? So, you know, the little dance that we saw here with the request and the response, well, you might want to layer mutually authenticated TLS into that, right? When you make your back channel fetch, you might want mutually authenticated TLS. Well, guess what? There's a little tiny spec that layers on top, right, that'll give you mutually authenticated TLS. Maybe what you want to do, so when you go and you fetch your tokens, you need to authenticate, right? You need to have your authorization code and you need to authenticate to get your tokens. Maybe what you want to do is have your client authenticate with a JOT, right? So instead of sending a client secret, which is just another password, maybe you actually want to go fully passwordless, both for your clients and for your users. Well, there's a spec for that, right? So all these specifications are coming out in the OpenID Foundation and coming out in the IETF to crank the dials on every facet of how you might want to toss tokens back and forth, right? There is a specification to do token introspection, right? So you're an API, and somebody's just thrown you a token. What are you going to do with it? Well, it turns out that there's a standardized endpoint that you can stand up and run so that your APIs can go look at that token and get back information on it. So they don't even have to do the validation themselves. They can just call another service to do that, right? So what OpenID Connect represents is this sort of cool patchwork of new functionality that can get layered on to serve whatever your security needs are. Let's see, what else? This certifiable piece of it is really important. So when SAML was young, there was a lot of certification that happened, and it was extremely expensive. So you had to spend $50,000 to $100,000 to have your product certified as properly complying. Well, that doesn't work when you have the Death Star to TIE Fighter model, right? Now you have a whole bunch of developers who are all writing stuff, right? And you kind of hope that they might use a library that could be certified. So we have a whole set of certification tests at the OpenID Foundation for relying parties who want to gather information from identity providers. And this is a super big deal because, breaches happen because people make mistakes, right? So you have one guy who forgets one line of code, and all of a sudden your relying party will accept anyone at any time for any reason, right? They will validate anyone. It has happened. There was an example not very long ago of a misconfigured relying party site that it turned out that you could send any assertion with any signature at all, and they would just assume you were the person who was in the assertion because they didn't actually validate the signature. They just read the document and they went, oh, you're Mel Gibson, great. Come on in, be part of our party. So that's not so great. So we think that certification and self-service certification is going to be a really big deal for OpenID Connect as well. All right. So we've seen the ID tokens and access tokens. I've got 12 minutes left, and I want to make sure we get to FIDO. You can always talk about FIDO, or we can talk about the other stuff after if we need to. But just going back to our model, right? Back to our cloud as the identity plane. What about this square? What's exciting about this square? Well, the only thing that's different about this quadrant of the identity as a control plane diagram is who the authoritative source for the identities and for the data are, right? So if you have a supply chain, right, or you have a customer repository, you may want to consume data into Azure Active Directory rather than emitting data, right? So in this case, what you might want to do is be the relying party and have other people serve data to you. Well, guess what? The standards are all the same, right? It's just the positions that change. So you can configure Azure Active Directory to be a relying party to social networks or to external federation identity providers like your big partners or your supply chain, right? It's all exactly the same. The standards are identical. The only difference is who's sending the data and who's picking up the data. And by the way, if you were in Alex's keynote, Alex Simons, that is, he talked about decentralized identities, right? Wouldn't it be cool if you could own your own identity and your identity could exist independently of any service and you could still get access to services, right? Maybe your data's on the blockchain, right? Or maybe your keys, your public keys are on the blockchain, right? And you're protecting information about yourself and releasing it when you feel like it, right? This standard, the standards we've been talking about completely support that model. It's just a different type of data, but the actual dance of trust is the same. All right, now we get to the fun stuff, right? The very, very fun stuff. I've been in identity for a long, long time, and it's really tough sometimes to be a vendor in identity because some new cool thing will come out, right? Wow, we've got, we have secure ID tokens, and we have Symantec tokens, and we have these other tokens. Well, guess, you might find an authentication method that rocks your boat, right? That exactly meets your security requirements. And guess what the next thing you've always had to do? Go find vendor support for that thing, right? So then you have to sit there and you have to wait until enough customers form enough of a movement that makes sense for the vendor to do a proprietary integration to your authenticator, right? That's a long, miserable process. So the question becomes, what abstraction layer could we put in the middle so that you can choose any authenticator you want, right? Anything, and we can support it, right? We need a way to not have to care about the proprietary details and to treat every single authenticator the same. Well, that's what FIDO 2.0 is. And I think you've heard a lot about FIDO 2 this time around. So I'm just going to sort of stay down in the weeds and talk in the weeds. But the important thing to understand about FIDO, the thing to take back to your bosses on FIDO, it is high assurance, strong authentication. And one of the most interesting things about it is that it's unphishable. The reason why it's unphishable is that it's asymmetric in trust. Okay? And the asymmetry in trust is based on the domain. So if you think about what it means to have your password phished, right? What's really happening? Well, you're seeing a web page that looks just like one that you know and trust, and you can't tell the difference, right? You can't tell the difference between, Salesforce.com and SalesforceXYZ.com, right? It's just they're too close, and you don't have any way to discriminate. Well, computers can. They can tell the difference. They know when a URL is different, when a web origin is different. So you can't just fool somebody into providing an authentication. And even if they do, what comes out the other end is different. And that's why it's unphishable. So the example I have here, I'm just going to log in while we do this. The example here is, in my mind, of course, the stormtrooper, right? So why is it that a rebel, that the rebel scum can pick up a stormtrooper's helmet and put it on, and the heads-up display starts for them? Like, why does that even happen, right? It doesn't even make any sense. Like there should be no Star Wars movies because no one should have ever been able to put the stupid hat on in the first place, right? So the question is, what if we wanted to make that stormtrooper hat into an authenticator, right? Well, you could have multiple factors. You could have a ton of business logic. You could be accessing databases in the back end, right? Whatever that thing is, however complex it is, with FIDO, what it resolves to is a public-private key. Okay, so what I'm going to show you is how the authenticators do their magic, right, and resolve to a private key, and they deliver a public key to as an identifier that can be used for external resources. Why is this important? Well, obviously you get the choice, right? It also means that there's an ecosystem that can build. We don't even know what kind of amazing authenticators could grow in our ecosystem tomorrow, but it doesn't matter, right? You can go, you can try it, right? You can be sold on the reasons for yourself. You don't have to just select from a set that we're picking for you. All right, so let's switch this baby over. This is the last demo of the day. Well, my day. I don't know about you guys. All right, so I'm going to show you the WebAuthn support that's built into the Edge browser. And I'm going to show you sort of on the console what it looks like when that authentication occurs. So the important thing about the FIDO2 protocol is it's actually two protocols in reality. It's a protocol called CTAP, C-T-A-P, and a protocol called WebAuthn. CTAP is the protocol you never, ever want to try to read. It's really nasty. It actually uses assertions, just like what you've seen in SAML, except they're in this format called CBOR, which means that it's been made very, very small, and it's basically impossible. It's like machine language. Anyone who's done assembly language will understand what I'm talking about. So CTAP is a way to talk to an authenticator that is external to a device. This is an example of an external authenticator. Okay, so the transport protocol for this is USB, but it doesn't have to be. FIDO CTAP will allow you, in fact, to do 3 transport mechanisms: NFC, USB, and Bluetooth is the other one. Okay, so all 3 of those things have very different geeky interaction models, but they resolve to the same thing, right? So this is an example of an external authenticator. Windows Hello can talk to this device, right, using CTAP. Windows Hello itself is a CTAP authenticator. And what that means is that any authenticator that's built into Windows Hello becomes what are called platform authenticators. So that's the facial recognition, that's pins, that is fingerprint readers, all of those sort of things that are built into the platform now become available, right? But everything I've described so far is device, right? The stuff on the device. What happens if you have a web server in the cloud, right? How does a web server in the cloud launch a device interaction? Well, that's what WebAuthn is for. So WebAuthn is a specification that has actually been ratified or is about to be ratified in the W3C. So it's in a different standards body, but it's a JavaScript API that allows a web server to tell the browser, to tell the hardware that some device interaction should happen, right? So it's super cool. All right, let's try this. Dun, dun, dun. Make it bigger. All right, let's do the platform authenticator first. So you can see there's 2 buttons, register and authenticate. That's because that is all that FIDO does, okay? When you register somebody on a FIDO authenticator, you are literally generating a public-private key pair for that user on the device, okay? So you can have as many users register key pairs on the devices you want, right? It manages those keys per user, and it also manages them per origin, and I'll show you what that means in a second here. So I'm going to register myself on this little Go, and in this case, I've got a PIN set up. Windows Hello believes that that's the corporate authentication mechanism. So, all right, I'm now registered. So that means there's now a key pair, right, that Windows Hello is managing on this device for me, such that the next time I come back, it can recognize that key pair and serve it back, right? What you can see on the right-hand side here, there's a WebAuthn create call that happened. There was a challenge and response that came back. And there's an identifier, right? So the identifier is down here on the left-hand side, right? And it's a big, nasty, base64 encoded thing, right? So now, anytime I come back to this computer, I can authenticate, and that same string will be served when I authenticate from Windows Hello, right? Super easy. Let's do the roaming one now. I'm going to plug her in. All right, so it's plugged in, and I'm going to change it to a cross-platform authenticator. I'm going to do the same registration. And this time it's asking for the PIN that's associated to my roaming authenticator. So why is this important? This is important because not everybody has built-in fancy biometric stuff on their laptop, right? So the use cases for these external authenticators are different. All right, so now you can see what's happened here is I have to take action on the security key. So literally the private key on this authenticator does not get unlocked unless I press the little blinky button here, right? So it doesn't have, you can't just go plug it in places or have it happen transparently. I have to actually unlock the private key, which I do right there. And boom, the same thing happens, right? So it doesn't matter whether it's biometrics, it doesn't matter if it's some fancy stormtrooper hats, you always get the same identifier back, and that identifier is always public-private key. Now, the other thing that you should notice here is the origin. So this origin is webauthn_sample.azurewebsites.net. The public key that's being served for this user will never, ever be served to any other website except the WebAuthn website. So it doesn't matter how good the phishers make their fancy web page look. Even if they fool you into tapping on your key and releasing the private key, it's a different private key for a different origin. And that's what kind of makes it cool, right? Or one of the reasons, anyway. All right. And again, you guys can do this on your own. Nothing I'm showing here takes very much preparation at all. And it's all you need is the browser, right, in order to see this stuff. And just knowledge of how to pull up, the console or the debugging tools. All right, I want to cover one last thing really super quick because I'm about to get kicked off the stage. There is one other quadrant of this diagram, and that's your on-premises quadrant. Well, guess what? It uses standards too. Isn't that cool? Everybody uses standards. So if it's AD Connect or if it's ADFS, they're all using SAML, they're all using OpenID Connect, right? And the reason for this is because it scales, right? When you do the things the same every single way, or same way every single time, it doesn't matter whether you have one customer using it or 100 customers using it. It's all the same, right? You can easily grow and handle multiple scenarios. Now, there are standards that occur really only on premises, and those are those that are not internet grade. So you look at LDAP, you look at Kerberos, right? Still incredibly valuable things. They just occur within a certain domain, and if you need to go outside of that domain, you need to translate the identities. And in general, what that means is an LDAP bind to authenticate the user with a password, for example, that then turns into a SAML assertion that gets sent, off the reservation, so to speak. So that is the honest truth, right? At Microsoft, we build a lot of additional stuff in, but we try to hang everything off of standards so that it's something that you guys can understand, your auditors can understand. It's something you can hire people for. Right? If you have SAML expertise right now, you can get a job anywhere, right? It works at Google, it works at Salesforce, it works in private enterprises, it works at GE, it works everywhere you can imagine, right? So the repeatable nature of this is one of the best selling points. All right, and on that, I will get off the stage before people start attacking in hunger. But I do want to say, if this is interesting to you, then there's a bunch of stuff you can do, right? Look at where your identities flow. Look at where you can rely on central authentication ceremonies, and see what you can do to stitch things together. And I will leave you with that, but thank you very much for your time. I really appreciate it.